Hello and good evening, everyone. Welcome to the third episode of Tech Talks 101 powered by F Labs, bringing to you the latest technological developments in the field of research and development and also the latest technological implementations in the industry. So in the previous episodes, we had discussions about ongoing researches on cybersecurity and hardware security. And today we are bringing to you a new episode on the fields of wireless communication and 6G. So to talk with us about wireless communication and 6G and his research, we have an interesting profile today. He is currently pursuing his PhD at the Center for Wireless Communications at the University of Oulu, Finland, and he is also a former graduate from the Faculty of Engineering of University of Moratuwa, graduating from the Department of Electronics and Telecommunications Engineering, and he is also a former electronics engineer at S01 Incorporation, and he was also placed Island 16th in the GCE A-level examination held in the year 2012. So today with us we have Mr. Dileepa Marasinghe. Hello, Mr. Dileepa. How are you doing? How is life happening to you these days?
Hello, Pamalji. Yeah, I'm doing good these days. It's summertime here, so it's fun time actually. And thanks for inviting me to this session. Let's hope this will be an interesting session.
Yes, great. So it's a great pleasure to have you here with us today, and thank you for accepting the invitation as well. First and foremost. So starting off the discussion, could you please tell us a bit about your academic background, where you're from, and where did you school, and how did you get into this path of higher studies and education? Like, how has your journey been so far?
Yeah, so I am originally from Badulla. So I did my O levels in Uva Science College, Haliala, and my A levels in Badulla Central College. Then after A levels, I got into University of Moratuwa, and after the first semester exams, I opted to go to Electronics and Telecommunication department. And then after semester five with the industrial training, I got my internship position at Zone 24/7, and I was fortunate to get the after graduation work also there as an electronics engineer. I worked there for like 7 months, and then I moved here for my masters to Finland, Oulu, Finland, and I finished my masters in 2019, and then since then I have been doing my PhD here. Now it's about 1.5 years, and that's my way here.
Okay, great. So today we'll be speaking about his research in sensor-aided high-frequency beam management, contributing to his project of 6G flagship. So we'll talk a lot in detail about this research, but before moving forward into in depth about these details, uh, you mentioned that you did your master's and then moved into your PhD. So was there any specific reason why you did look into this particular sector of wireless communication while when looking for opportunities for your masters? And also, like, how did you come across these opportunities? How did things happen for you when you were looking for your higher studies opportunities?
Yeah. So when I entered University of Toronto, I didn't have like much idea of going for higher studies. But during my internship, I felt like I needed to go for higher studies and do a master's, like pursue a master's and a PhD. So then after graduating, I was searching for actually before graduating, but I was searching for opportunities, and I was thinking about wireless communications, telecommunications in general, and also computer vision, and those areas. And I we got to know about the opportunity here from one of the senior ENTC alumni, and then I applied here, and I was chosen for the masters. So uh, then I came here for my masters, and we had the possibility of going for PhD also. So that's how my way uh, to here. Yeah.
Okay, that's very interesting. So, moving into Finland, moving into Europe, like, one thing that we see is like a lot of people when looking for their higher studies opportunities, they are more or less inclined towards finding their opportunities in the United States of America or Canada, or when it comes to the Asia Pacific Pacific regions, countries like Australia, New Zealand. So recently we have seen a lot of people moving, trying to get into their higher studies opportunities in Europe as well. So how has Europe as a region and Finland as a country accommodated you in terms of for you to pursue your higher studies? How has the experience been there in Europe and Finland? And how has your higher studies experience been, where you know getting exposed to a global crowd and getting exposed to a global community of academics and pursuing your academics there?
Yeah. So the main reason I got here, like it was Europe, and when we talk about the higher studies in Europe, I think there are a lot of prestigious universities in Europe, in countries like Switzerland, Germany, and Finland. So there are like world top ranking universities, and because of that, then when we talk about these European countries, there is like good social security. They are good, very good countries to live also. So I think Europe is a good destination for higher studies, and particularly if I talk about Finland, where I am, Finland is a very so it's called this happiest country in the world. So, and there's a very good social security system here, and it's the education system is also top in the world here. So I think Finland in general is a very good destination for higher studies. And if I talk about my experience here for my higher studies, it has we have like a really good exposure for the international crowd, and particularly in my field of study, wireless communication, where I am. It's called Center for Wireless Communication at University of Oulu. So this place has a very good reputation in wireless communications industry and academia. And also, as you know, Nokia is also from Finland. So we have the background for wireless communications is in Finland anyway. And if I talk about life here, uh, it has been really good. So we get the chance to travel a lot as we are in this European region. So I've been to around like 7 countries, and because of this Corona, we couldn't travel anymore. But in the initial years, we had some traveling done, and also in Finland, we get to see these northern lights, and there's midnight sun, and there's a long winter. So it's really a different and a good experience so far. And yeah, that's how my life here has been as doing my higher studies.
I'm sure like it must have been a very impressive experience for you out there. So speaking of which, on today's topic about your research on sensor aided high frequency beam management, before moving to in detail of your research, I just have a few questions to just to set the background for your research, so that the listeners that we have here would understand how this research sums up, and in what direction are you proceeding in this research. So my first question is, when it comes to wireless communication, the when it comes to countries like Sri Lanka, the implementation is 4G, but all around the world 5G is the latest implementation. So could you please tell us a bit about what 5G is, and like what are the specifications or the key highlights of 5G?
Yeah, so when we talk about 5G, 5G is basically a faster and more unified kind of network than 4G. That is targeted for like three main use cases. They are called this EMBB, it's called Enhanced Mobile Broadband, and URLLC, Ultra Reliable Low Latency Communications, and MMTC, so Massive Machine Type Communication. So EMBB is basically giving you like highest data rates for applications like video streaming, and so higher data rates. The target is that. And in URLLC, you have this ultra reliable. So the reliability and low latency is needed. And so use cases like doing vehicular communications or industrial automation. Those kind of stuff are considered in URLLC. And when we talk about MMTC, so the current 4G networks doesn't have like much support for this IoT kind of communication. So MMTC is targeted towards machine type communications, where communications between these small nodes happen. So I would say 5G is like a more unified network than 4G for catering different use cases and different verticals. And also in 5G, one key highlight is we will be using this higher frequencies than what we use in 4G. So in 4G, we use frequencies around 2.6 gigahertz, and in 5G, it is expected to be used like currently the implementations are going on for frequencies up to 60 gigahertz. So these ranges are the highest ranges are called millimeter wave, and this enables giving more like faster communication links and with lower latencies and higher data rates because we can use there's a lot of bandwidth available in those frequencies. So if we talk about numbers, in 5G, the peak data rates will be around 10 to 20 Gbps, and latency is expected to be like the standard is for 1 millisecond latency, and there will be like 99.999% reliability. So that's basically 5G, and I think 5G is currently being rolled out around the world, and I hope it will be coming to Sri Lanka as well soon.
Okay, so 5G is currently being rolled out around the world, but when it comes to your research, it is actually not about 5G. It's about 6G flagship moving forward from there. So could you tell us a bit about, what's the way forward from 5G to 6G? But how do you see the future in 6G? How the future would be with 6G?
So there is this in research, there's this big gap between research and what is really being deployed. So actually, research is looking way beyond like 10 more years, let's say 2030s, and 6G research is setting what will be wireless networks in 2030s and in the future. So 6G is basically more faster than, it's expected to be more faster than 5G, say 100 Gbps or 1 Tbps connections, and even reducing more latency, let's say 0.1 milliseconds. And there will be like very extreme use cases, like where you can perform remote surgery where the doctor is in one corner of the world and the patient is in another corner of the world. So this remote surgery kind of use cases it's expected to be like deployed. So 6G's another main highlight will be increased use of this AI and ML techniques. So the network will be more intelligent and data driven. So there will be AI ML deployed in almost all layers of the network. So it's expected to be more intelligent actually. And and there will be another thing, we will be going towards more higher frequencies into terahertz region. So that is beyond this millimeter wave. So that will also be there. And another key highlight will be increased use of this sensing that will use other types of sensors to make environmental awareness about the surrounding for the network, so that the network can take decisions and run algorithms more intelligently to deliver more high speed and high reliabilities. So when I talk about sensing, that means sensors like LiDARs, cameras, and there's this millimeter wave radars, terahertz imaging, those kind of things. So 6G, if I say 6G vision for 2030 is what we have here is it's data driven, near instant, unlimited wireless connectivity.
Okay, that's something very interesting to like listen about. So another important key aspect that we need to talk about before moving to in specifics of your research is about beam management. So when it comes to wireless communication, could you please tell us a bit about what beam management is and what exactly people look into when they do or work in beam they engage in beam management, what they do?
Yeah. As I said, compared to 4G, we will be using higher frequencies like millimeter wave, and 6G it will be like way going beyond like terahertz. So when we go to these higher frequencies, that means the wavelengths are getting smaller, and we can use a lot of antennas uh, in let's say mobile phones or something like that. So this will be It's called MIMO antenna, so massive array of antennas, and those beam patterns can be made into beams that the radiation pattern will be formed as beams, which means we can concentrate the energy of the uh, antenna towards a certain direction. So that is the idea of forming a beam, and the advantages of doing that is like we can give directional communication so that we can cater multiple users like directionally, and we can reduce interference. And there's this problem when we go to these higher frequencies, there is higher propagation loss. So there is increased reducing of this energy when the distance is increasing. So if we direct more energy towards one direction, so we can cater a longer distance, and also direct so as I said, it's directing energy towards that. And so that's a beam. So in beam, so when we talk about this 5G and current standards, there are two things that we have to do. So when a mobile phone or a user is connecting to the network should identify which beam to serve to that user, because it's directional communication, not like omnidirectional, what we have as in 4G or earlier networks. So these beams has to be identified, and if the users are moving, then the beams have to be changed accordingly, appropriately, so that it can track the movement of the user and change the beam accordingly. So there is that. So these type of procedures, these are all included in this beam management. So how to do this like efficiently so that we can serve more users with increased data rates and lower latency. So this is all in beam management.
Okay, so your research sensated high frequency beam management. So what are things that you are doing in your research? Like how do you integrate how do you use the sensors to manage the beams of these higher frequencies? Like what is the way forward in your research? What are things that you're looking into in your research?
Yeah, so as I said, the transmitters has to identify which beams to serve. So that means the sense of direction where the user needs to be known in the transmitter. And for now, in the current millimeter wave networks, what they do is like broadcast different like direct beams into different like sweep around and choose those beams. That is what is currently done. And what I am trying to do, so those are based on RF data, but what I am trying to do is use these other sensors that can give environmental awareness to the transmitter and give the perception of the environment, so that where the users are basically giving information about the positioning of the users. So for that, I am trying to use these LiDARs and cameras and these millimeter wave radars, so that we can use this to identify where the users are, and if the users are moving, uh, identify the track the movement of the users, and give those information to the transmitter or the base station, and the base station can uh, actually take a predictive decision about which beams to serve. And one thing that I am focusing right now is, as I said earlier, also there is this higher propagation loss and the problem of blockage in using these higher frequencies. So if the user moves, if there's a link that is ongoing, and if someone moves through that link, then the link gets blocked in these higher frequencies compared to the earlier like sub 6 gigahertz, that means lower frequencies. So the probability of blockage is higher. And if the user moves to a shadowing region in the lower frequencies, we can use this multipath uh, components, and the signal quality won't drop much. But in these higher frequencies, the signal quality will drop uh, like immediately. So if the transmitter can identify in the future, let's say 5 seconds in the future, if there is a blockage coming, or if the user is moving to a shadowing region that we can't serve directly. So that means the user is going to lose the line of sight communication. So if these kind of measures can be known before in a predictive manner, the transmitter can do the beam management procedures intelligently. So that is what I am currently trying to do, use LiDAR data to identify where the users are, then see whether, predict whether the users are going to be blocked or not, and then uh, also predict what are the beams that can be used in the future. So that is what I am currently doing, and I am using deep learning techniques and computer vision, and combine the data with the what we have from RF side, uh, trying to achieve this, and the research is actually ongoing.
Great. So, moving forward with your research, like you mentioned, there's always a gap between where the research and development of where the research and development is placed, and also what has been already implemented in the industry. So, what are the measures that you take to bridge this gap while you move forward with your research? Do you have any collaborations with external organizations that are currently established in the industry, or is there any other thing that you do?
Yeah, so in Finland, there's a lot of possibility. Basically, in Europe, there's this possibility of having collaborations with industries a lot. Uh, and as I said earlier, also Nokia is here, so we have some collaborations with them. And also, there are these industrial related projects that we get to participate in, where there are a lot of companies from all over Europe. One is called this HexaX project. So it's also like working towards this 6G developments. And I think there's a lot of opportunities for us to collaborate with industry as well. So bridging this gap between the industry and the research, and they are also interested in what we do, and they give comments to our work, and we try to incorporate our work with their work, and have a industry capable solution, and also working towards this. There's this thing called standardization, where there's an organization called 3GPP, where the telecommunication standardization is done. So that is where these 3G, 4G standards have been documented, or like setting the standards. That's what they do, and we try to work with these companies and try to uh, work our way if our work can be moved to these standards as well. So I think there is a lot of collaborations, and it's really a good opportunity when you are in a country like Finland for wireless communications to have these opportunities.
Of course. So, yeah, we've had a very inspirational and fruitful discussion about your research in wireless communication and 6G. So, before winding up, there's one last question that I need to ask you. I believe this will be important for any of the undergraduate listeners that we have here with us. So, when applying for higher studies in Europe specifically and in Finland, so what is the exact process of applying for the higher studies? Is there any specific window for looking into the higher studies? Is there any specific method of approaching professors? So what is the piece of advice that you could give on this regard?
Yeah, so in my case, I already knew about the opportunity here. So if I talk about wireless communications and the masters in the university where I am, so there is this opportunity of joining for masters in wireless communication and pursuing a PhD also here. Uh, as I said earlier, also like we are in this project called 6G flagship. There are a lot of opportunities available for masters in our area and also this computer science and all. And there's the possibility of getting research scholarships and research assistant positions, stuff like that. So if I talk about the window, I think basically in Europe to enter to this PhD opportunities, I think you have to have a master's program, master's degree, or you need to first go to the master's and then go to the PhD position. And the window for master's opportunities around Europe, I think it opens around November to January in the year, targeting these fall semesters. And basically, you can directly apply, I think. So and for positions, I mean, for research advisors and let's say having more contacts, you can of course email the professors. But I think it's basically applying directly towards these opportunities. Do a thorough research on the web. All these opportunities are available. They advertise them a lot, and I think I have seen some Facebook groups also, like offering like they also post these opportunities, and there's also this Marie Curie, I think, program where researchers can join like for PhD positions, and it's more industry related, but I think there are opportunities like that also. So if you do a thorough search and also do this direct applying, I think there is the possibility of getting the chances to come to Europe for higher studies. And also there are a lot of possibilities for scholarships, because in as I know, this European region promotes getting talents all around the world to here, and they are trying to like uplift the research here.
Yeah, so that's one piece
And
of
yeah,
yes.
and I would like to add like if you want to specifically know about the work that we do here and also opportunities here, I would suggest please go to this 6G flagship website in our university. So particularly to wireless communication and computer science, there are opportunities posted there, and you can also see what kind of work done in our Center for Wireless Communication with this. There are like white papers about 6G, like 12 white papers. So you can actually see what are the opportunities and what kind of possibilities for you are here. Yeah.
Thank you very much. So that's a great piece of information advice for all the undergraduate listeners we have here with us. So anyone who is interested in pursuing their higher studies in wireless communication, I believe that would be Finland would be a great destination to go forward with it. And like Mr. Dileepa mentioned, you can check more about his the projects that is going around in Finland in the Center of Wireless Communication under 6G flagship. And yes, so slowly we have come to the end of our discussion, the episode 3 of Tech Talks 101 powered by F Code Labs. So today with us we had Mr. Dileepa Marasinghe. He's pursuing his PhD at the Center of Wireless Communication of University of Oulu, Finland. And his PhD is in sensor-aided high-frequency beam management. So thank you very much, Mr. Dileepa Marasinghe, for joining with us today. It has been a great pleasure and a privilege to have you here with us. And we wish you all the best in your PhD studies and all the other ventures that you are going to go forward with. Thank you very much, Mr. Dileepa.
Yeah, thank you, Pamaljit, for inviting me for this session as well. And also, it has been like a good session for me to express what we do here and talk about the opportunities here, actually. And I hope you keep this going and inspire the the younger generations, like the people that are interested to come to higher studies. Yeah, thank you very much.
Absolutely. So, if anyone wants to get in further touch with Mr. Dileepa Marasinghe, you could get in touch with him through Facebook and also LinkedIn, and he would try his best to support you through and help you through whatever you need to know about any information. So, if also if anyone has not yet viewed our previous episodes, you can view them through our Facebook page, Tech Talks 101, and also we are on YouTube, and you can also listen to our podcast on Spotify, Google Podcast, and Apple Podcast. So, thank you very much for joining with us today, and I wish every one of you a great night and stay safe, stay healthy. So, we'll get connect with you guys again with our fourth episode. Until then, stay safe. Thank you very much.